Hello everyone, welcome back to my YouTube channel Physics by Garima. I hope you found my previous videos helpful. In today's video, we are going to solve CSA physics exam that is conducted on 25 April. So let's start with the question number 1. Which of the following physical quantity is a scalar? Option A, displacement. Option B, acceleration. Option C, force. Option D, work. Here, displacement is a vector quantity, acceleration is a vector quantity, force is a vector quantity, and we know that work done is equal to F dot S. This is a dot product of two vectors. That means which is the scalar quantity. So according to this, work is a scalar quantity. So option D is correct. Question number 2. An object's weight on moon is about one-sixth of its weight on Earth. If the object has a mass of 6 kg and acceleration due to gravity on Earth g is equal to 10 meter per second, its weight on moon is. Here, the weight of moon is given as one-sixth of weight on Earth. And we know that weight on Earth is m times g, where m is mass and g is acceleration due to gravity. Here mass is given as 6 and acceleration is given as 10. So after solving this, we will get 10 Newton. So option B is correct. Question number 3. A spring has a spring constant K 50 Newton meter 50 Newton per meter and original length of 10 centimeter. If it is stretched to 14 centimeter, the magnitude of pulling force is. Here, spring constant K is given as 50 Newton per meter and original length is given as, suppose L naught is original length, it is given as 10 centimeter. And final length, it is stretched to 14 centimeter. So final length is 14 centimeter. So we have to find the pulling force. We know that pulling force is equal to K times X, where K is spring constant, X is change in length, or we can write it as delta X. So here we will put the value of K, that is 50, into change in length will be L final minus L initial. So 50 into L final is given as 14 minus L initial at 10 centimeter. Now we will convert centimeter into meter. That means it will be 10 raised to power minus 2. When we solve this, 14 minus 10 is 4 into 10 raised to power minus 2. 50 into 4 is 200 into 10 raised to power minus 2. So it will become 2 Newton. So option C is correct. Question number 4. An object of mass 5 kg is placed on a horizontal surface. The coefficient of friction is 0.2. A horizontal force of 8 Newton is used to pull the object. The magnitude of frictional force is. Here G is given as 10 meter per second square. So according to question, mass is 5 kg and coefficient of friction mu is given as 0.2. Horizontal force that is applied is 8 Newton, and here we have to find the friction force. Suppose this is the object of mass m and we are applying a force. So the friction force will be opposite to the applying force, and we know that the maximum friction force is equal to mu times n, where n is normal reaction. So this will be normal reaction and this will be mg, which acts in downward direction. So a normal reaction and mg both are balanced. So mu times n, we can write n is equal to mg. Now we will put the value of mu, that is 0.2, into mass is given as 5 and g is given as 10. So this will become 10 Newton. This is the maximum friction force, that is 10 Newton, and we are applying a force of 8 Newton. Here, this friction force is greater than the applied force. That means the object will be at rest. So, the friction force will be equal to the applied force, that is equal to 8 Newton. So, according to this, option A is correct. That is 8 Newton. Question number 5. Three forces with a magnitude of 3 Newton, 4 Newton, 5 Newton act on the same object. The maximum magnitude of their resultant force is. So here three forces are given. Suppose first force F1 is 3 Newton, F2 is 4 Newton, and F3 is 5 Newton. And we have to calculate the maximum resultant force. So maximum resultant force will be equal to sum of all these forces, that is F1 plus F2 plus F3. So we will put F1, that is 3 plus 4 plus 5, which will be equal to 12 Newton. So option B is correct. Question number 6. Two forces of magnitude 15 Newton and 5 Newton act in opposite directions. The magnitude of their resultant force is. Here two forces are acting, that is 15 Newton and 5 Newton, and these two forces are opposite in direction. So suppose F1 15 Newton is in this direction and F is in this 5 Newton is in this direction. So net force will be equal to resultant force will be equal to 15 Newton minus 5, that is 10 Newton. So according to this, option B is correct. Question number 7. Three element of force are magnitude, direction, and the third is the third is option A is given as nature, option B point of application, C object of action, D effect. So its answer will be point of application, that force depends upon the point of application. So according to this, option B is correct. Now move to question number 8. An object starts from rest and accelerates uniformly at a is equal to 3 meter per second. Its velocity at the end of 5 seconds is. Here the object is at rest, that means initial velocity is 0, acceleration is 3 meter per second square, and time is given as 5 seconds. So we have to find the velocity. We know that velocity is equal to u plus at. Here u is given as 0 plus acceleration is 3 and time is 5. So velocity will become 15 meter per second. So according to this, option D is correct. Question number 9. An object of mass 2 kg is acted by a 10 Newton pulling force on a horizontal surface. If coefficient of friction is 0.2, the acceleration of the object is. Here, the mass of object is given as 2 kg and applying force or pulling force is 10 Newton. Coefficient of friction mu is given as 0.2 and we have to calculate the acceleration. Suppose this is the object and 10 Newton of force is applying in this direction and friction force will be opposite to the applied force, that will be the friction, and we know that the friction force, maximum friction force is mu times m, mu times mg or mu times normal reaction. Friction force is equal to, that is the maximum friction force is equal to mu times n. So we can put n is equal to mg because normal reaction and these downward force, that is the gravitational force, these two forces are equal. Now we will put the value of mu. This is given as 0.2, mass is given as 2 and acceleration is given as 10. So this will become 4 Newton. Here, the maximum pulling force, that is friction, pulling force is greater than friction force. So net force will be equal to net force will be equal to 10 minus 4, that is equal to 6 Newton. So acceleration will be equal to net force by mass. So it will become 6 divided by mass is given as 2, that is 3 meter per second square. Here the object is still moving, that is why it is having the acceleration. So option B is correct, that is 3 meter per second square. Question number 10. An object slides down from rest from the top of inclined plane with an angle of inclination 30 degree. The displacement it travels in 2 seconds. Suppose this is the horizontal plane which is making angle 30 degree, and object is at this position. So the forces that is acting on this object will be normal reaction and the mg force. Now the component of forces will be mg sine theta, this is mg sine theta, and this will be mg cos 30 degree. Now we have to calculate the displacement. So we know that S is equal to ut plus half at square. Since object is at rest, so initial velocity will be 0 plus half. Acceleration is given as this. So this is force. We have to calculate the acceleration. So acceleration will be g sine 30 degree into time is 2 seconds. So this will become 10 into sine 30 is half and 2 square. So this get cancelled and the displacement is coming as 10 meter. So according to this, option A is correct. Question number 11. Two forces of 9 Newton and 12 Newton act on an object. The maximum possible acceleration is. So acceleration will be maximum if force is maximum. So maximum force on object will be the sum of the two forces, that is F1 plus F2, where F1 is given as 9 and F2 is given as 12. So this will become 21 Newton. So acceleration is equal to force by mass. Force is given as force is 21 and mass is 3. So acceleration will become 7 meter per second square. So according to this, option D is correct. Question number 12. During the process of two objects being charged by friction, the total amount of charge they possess. When there are two bodies, suppose this is the object, this is the body 1 and this is the another body 2. Okay, and we are charging these two bodies. So there will be transfer of electron. Okay, so one of the body will become positively charged and another body will become negatively charged. But if we consider the whole system will have the total net charge will be same. So its answer will be option A, that is the total charge of the system remains constant. Now move to question number 13. A particle undergoes uniformly circular motion with a linear velocity v is equal to 4 meter per second and radius r is equal to 2 meter per second. Its angular velocity is. Here, linear velocity v is given as 4 meter per second and radius is given as 2 meter. And we know that v is equal to r times omega. So omega is equal to v by r. Here velocity is given as 4 and radius is given as 2. So it will become 2 radian per second. So option A is correct. Question number 14. As shown in figure, an object moves from point A to point C along a semicircle of radius 4 meter taking 2 seconds. The magnitude of average velocity. So average velocity, we know that average velocity is equals to displacement by time. Since object is moving in a semicircular path, object is moving, suppose, from point A to B, and here radius is given as 4 meter, and displacement, we know that it is the shortest path, so shortest path will be AB. So it will become 4 meter plus 4 meter, that is 8 meter. So displacement will become 8 meter and time is given as 2 second. So it will become 4 meter per second. So its average velocity will be 4 meter per second. That is option A is correct. Question number 15. An object moves with a uniform linear motion on a horizontal surface. The friction force acting on it is 10 Newton. The magnitude of pulling force is. Here, suppose this is the object, and this object is moving with a constant velocity. Here it is given that it is moving with a uniform linear motion. The object is in linear motion, uniform linear motion. That means velocity is constant. If velocity is constant, that means acceleration is zero. If acceleration is zero, that means the net force acting on object will be zero. That means the pulling force will be equal to frictional force. So this force will be equal to friction force. So frictional force will also becomes 10 newtons. So according to this, option C is correct. Now move to question number 16. A spring has a length of 12 centimeter when subjected to 10 newton pulling force and a length of 14 centimeter when subjected to 20 newton pulling force. The original length of spring is. Here, suppose this is the spring 1 and we are applying a force of 10 newton and its displacement is 12 centimeter. Suppose this is x1 which is 10 centimeter, and now we are applying a force of 20 newton. So its extension will be 14 centimeter. Suppose this is x2 which is 14 centimeter, and the spring will have the original length. I am taking original length to be x naught, and we have to find the original length of the spring. So for spring 1, force is equal to k into change in length. So we will put the value of force, that is 10, is equal to k into change in length will be x1 minus x naught. So this will be equal to 10k into x1, that is 12 minus x naught. This is for the first force. And for second force, similarly we can write the this equation for second force. So F2 is equal to k times change in length. This will be equal to 20 is equal to k into change in length will be x2 minus x naught. So k into x2 is 14 minus x naught. This is equation 1 and this is equation 2. Now we will divide both the equation. So equation 2 divided by equation 1. So we will get 20 divided by 10 is equal to k into 14 minus x naught divided by k into 12 minus x naught. So this k get cancelled and this will become 2 into 12 minus x naught is equal to 14 minus x naught. So this will become 24 minus 2x naught is equal to 14 minus x naught. So this 24 minus 14 will be equal to x naught. So x naught is coming as 10 centimeter. So original length of the spring is 10 centimeter. Now move to question number 17. Which of the following statement about the force is wrong? Statement A, force is a reason for an object to change its motion. Yes, this statement is correct. That force changes the state of the motion. So this option is correct. Force is a vector as well as force is a vector and having both magnitude and direction. This is also correct. An object can have an exciting object but not receiving. If we apply any force on an object, and so there must be a receiving object. Without this, this force cannot act. So according to this option C is wrong, and option D says that a force is an effect on of an object on an object. So this statement is also correct. Only option C is wrong. Question number 18. An object of mass 4 kg slides from rest from top of inclined plane with the angle of inclination 30°. The magnitude of impulse due to gravity in 3 seconds is. So we can draw the diagram. So its diagram will be like here angle of inclination is given as 30°. An object of mass 4 kg. The force acting on these object will be normal reaction and the gravitational force. Now we will divide the component. This will become theta and this is mg cos 30° and this is mg sine 30°. Now we have to find the impulse. Impulse we know that impulse is equal to force into time. Here force is acting because of the mg sine theta. Because of this object is moving downward. So here we will put the value of force, that is mg sine 30° into time. Mass is given as 4 into g is given as 10. Sine 30 is 1/2 and time is 3 seconds. So its answer will be 60 Newton second. So option A is correct. Question number 19. A horizontal pulling force of 15 Newton moves an object a distance of 3 meter on a rough surface. If friction force is 5 Newton, then work done is. Here they are asking work done by pulling force. So this line is important. Work done by pulling force means we have to consider force of pulling. That is pulling force, that is F into displacement. Here pulling force is given as 15. So we will put the value of force, that is 15, into displacement is 3. So its answer will be 45 Joule. So according to this, option A is correct. Now move to our last question, that is question number 20. When sitting in a train moving at a constant speed, the tree outside the window appeared to moving backward. The reference frame is chosen. Here, since the object is moving or the train is moving with a constant speed, so the person is sitting in the train, and here the frame of reference is with respect to the person or with the train. That means option D is correct. That's all for today's. I hope you understand each and every question. Thanks for watching.